let's get started. Most of you who are here, I see all of you are here, so that's good. Thanks, and thanks for sitting through a little bit of intensive, overwhelming stuff. I promise that the stuff that is going to come next, although it's a little code heavy, the charts are really pretty to look at. So you'll have good resting point for your eyes as we move through these charts. So now we have another hour and a half to go. I've split it evenly between static maps for 45 minutes and interactive maps for the next 45 minutes. So these are probably some of the easiest ways to get started making static charts or static maps in R. You have the base plotting, the base R plotting ecosystem. You have the ggplot2 based ecosystem. And then there are certain ease of use packages that allow you to make maps really very quickly. The four ones that I typically end up using quite a lot are tmap, choroplethar, cartography, and ggmap. There are some other ones as well, but these are enough to get started with. So those are the ones that I put. And some of them end up augmenting either the base R plotting system or the ggplot2 system. So they are not completely on their own, but some of them have their own set of APIs and syntax. So they don't necessarily work with either base plotting or ggplot. They do their own thing. And you need to be aware of these subtle differences when you're working with plotting systems. So fair warning, a lot of code is going to follow now. I'll try to explain most of it as we go along. If not, you have access to the slides. If you have any questions, you can always ask me then and there, or you can ask me later on. But yeah, there is going to be a lot of code now. So to start with, we're going to start with like base R graphics plotting system. It works on all kind of spatial objects. All you really need to do is plot, give the spatial object, and if you want to add it to already present map, just go add equal to true. And you can set a lot of different points, like what color should it be, what size it should be, what legend should have on your map, those kind of things. It's just a matter of reading on those documentations as to how to do that. Base plotting is really, really powerful. It's been in R since, I think the inception of R. But it is cumbersome to create like good-looking maps from base plotting. One of the things that you'll probably hear people talk about is the default output of ggplot2 looks so much better than the default output of plot. That's true, but you can make equally attractive maps or plots from base plotting. It's just that it's a little cumbersome and not as intuitive as you see from ggplot2. But don't discard or don't completely write off base plotting. It is a powerful ecosystem for creating maps. How many of you guys know flowingdata.com or Netanyahu? Okay, a few of you. For those of you who don't know, if you like data-driven journalism, if you like data visualization, he's one of the guys you should be following, along with like Stephen Few and Edward Tufte and those guys. Right? He's one of the pioneers in visualization. And Netanyahu has a website called flowingdata.com. And he puts in a lot of R code over there, and from what I know, he's like a hardcore base plot user, right? He absolutely refuses to use ggplot2. And if you look at those plots, you'll be amazed. I mean, if anybody tells you that base plotting plots are really ugly, just point them to flowingdata.com to see what can be done with that. So saying that, let's start with a simple base plotting in R. The part one is data preparation, part two is the plotting stuff. I'm not going to go over the whole part of these things, but what I'm probably going to tell you is, I don't know if you can see the mouse. Okay, good. So this was essentially just creating that messes. I want to plot certain grid lines for the background to show where the latitude, longitudes are, so I need to calculate that using the grid lines. I have the actual point data as well as a polygon data to show the river around which the soil samples were created. And as you can see, I'm transferring them both to latitude, longitude coordinate systems. The reason I'm doing that is just because I want to plot in latitude, longitude. There's no real reason for converting that. But one of the things that you'll always should remember, no matter what plotting systems you're using, is when you're plotting spatial data, they should be in that all the data should be in the same coordinate reference system. If it's not, then things are not going to line up, or sometimes things will not even show up. If you do that, if you plot certain things and don't see things in those expected places, chances are that you have certain data in different CRS systems, and that's why it's not lining up. So as you can see, I've converted both my points as well as my river polygons into the same reference system, which is the latitude-longitude reference system. So plotting starts with, you plot basically the object, you plot the grid lines, you plot latitude, longitudes, you add certain text to it. I'll show you the results. I was hoping we had like 2 screens so that I can show results and the code side by side. It's a little difficult to explain what the code is because if you haven't really seen the results. But just by looking at it, like it's just plotting a bunch of things, it's adding text, it's adding legends, and so it's adding vector data and it's adding certain legends to that. And the result of that comes out to be like this. You see the river that is in that Norway region and the soil samples that were collected from it. And here I've chosen to size the locations from where those soil samples were taken based on the zinc content of the soil. So I'm probably going to do this a lot, like switch back and forth between code and the output. So here I had said, where was that? Yeah, there it is. CEX square root. So square root is basically just to make sure that that whatever mathematical transformation that is done for that is just to make sure that none of the plots or none of the circles is too big that it overwhelms everything else, right? So you need to make that a little bit proportional. And you just need to play with certain mathematical manipulations to figure out what works best. So it's a fairly nice plot, right? Like if you look at it, you can imagine seeing such a plot in maybe a scientific paper or even in a newspaper talking about certain these things. So this is just made with pure base plotting, but just by choosing some sensible aesthetic values, right? I don't have a whole lot of color over there. I just didn't feel like adding color was going to add any more value to it. You see the latitude, longitude values plotted. And so, yeah, I mean, I like it. It's a good chart to put in a publication. But there's not much extra data, like there are no labels, no other stuff, but you can always add that as you explore more about that. Sure, go ahead. Sure. Plot forget about this line, it's just a little this thing, but plot the grid lines, those are your latitude, longitude, plot your the actual points, plot your polygon, and then add the latitude, longitude labels to your grid lines and add a legend at the bottom. Another thing that you'll notice over here is when you create this CEX based on this property, you have to repeat that same calculation over here when you're plotting the legend. If I mess this up, it's gonna completely, the legend is not gonna align with what was actually plotted. While as with ggplot2, if you use ggplot2, you get legends for free, right? You do geom, whatever, and the legend for that geom is automatically generated for you. Base plotting doesn't work that way. So if you are making legends, make sure that you are repeating the same calculations that you did for the actual value that you had plotted, which I find a little odd, but that's how it works. So a little more complex example. Yeah. Oh, yeah. So basically, I wanted to set a bounding box. Like if you run this code, just that line, you're not going to see anything on the output. It just sets the bounding box for this thing. So spatial is the most top level class of the SP ecosystem. So you like spatial data frame, spatial, these things all inherit from spatial. So when you cast it as spatial, it just says this is the bounding box. So this is nothing really actually printed, but the plot now knows what is the bounding box for the data that needs to be plotted. That's it. And the reason I want to do that is because I want a little bit area outside of the bounding box. Like if you see, I'm expanding the bounding box by a little bit so that I can accommodate my labels and my, the latitude, longitude lines and the labels for them. So that's what that line is doing. a little more complex example, and I promise you, you'll love the result of this. At least I do this. The result of that is like my favorite chart of that, and I've showed it to a bunch of people, and they liked it as well. What we're going to do is plot the world, and then plot all the cities in the world that have population greater than 1 million, just to see where population density is around the world, right? It's a very simple thing. I get the world data from like maps. Maps package has this thing called world data, so I took the world cities package from there. I only took the cities which have population more than 1 million. I converted it into a spatial object as I shown you before. And for plotting the actual world polygons, I used the R natural earth package. And I just used the countries 110 data set, which is like probably one of the quickest ways to get the whole world polygons in one line. And by the way, the author of that is over here. He's attending the talk. So where are you, Andy? Over there, yeah, that's the guy. If you want to talk about our natural language, he's the guy. And he's written some other packages as well. So I took out Antarctica. Antarctica, I'm absolutely sure, has no city which has population greater than 1 million. So I plotted. Grid lines for showing the latitude, longitudes. Again, this thing, same thing. I wanted to expand the spatial bounding box a little bit so that I can fit certain other information over there. I plot the world. I plot the grid lines. I plot the labels for my grid lines, the latitude, longitude values. I plot the world cities. And then I plot a legend. So it exactly looks like that previous chart, but here the data processing is a little more because I have polygon data and I have the world cities data. So here I'm plotting two different data sets, and the result looks like this. I like it. I mean, it is minimalistic, but it gives that information really nicely. It is not contrasting enough over here to show you the actual grid lines. Like, I just wish there was a better contrast over here to show you that. But if you were to look it on your laptop screens, you'll see some nice grid lines around it. And you have the legend at the top, and you have the world cities. And I don't need to tell you that India and China dominate that. So, yeah. So, yeah, that's it. And again, this is a SVG. The reason that it looks so pretty over here, so like, sharp and focused, is because it's SVG rather than a PNG or a JPEG. Sure. Oh, that is done automatically for you. Yep. I found it out myself when I was making that. Now, does anybody think I cheated a little bit or something is missing from the code I showed you for this plot? Yes, no? So the data that I plotted was in latitude, longitude. And if you plot latitude, longitude as is, you're not going to see the data like this. You're not going to see this curvature that you're seeing over here. That's a projection. So projection is basically a way of representing. How many of you guys know what projections are? Okay, a lot of you know. For those of you who don't know, just quick introduction. Projection is a way of representing a point on a 3D surface on a 2D surface, right? You're projecting from 3D into 2D. And there are various projections. There is no such one best projection to use. So the typical projections that you use for world map may not be the same projections that you'll use for a section. So if you want to plot North America, you're not going to use that same projection that you'll probably use for world map. So here I have used projections. I didn't show you that code for projections. I just showed you the code for, like if you look at it, the code over here was using latitude, longitude. This is the code for basically anything that is in latitude, longitude. So the code that you have for projection, the projection I use over here is called Winkle triple. There are n number of good projections that you can use for world plotting. And then there are n number of projections that you can use at a country level, at a local level, stuff like that. Just a fascinating topic to read up on. So this is the basic code that I needed to do to convert everything into Winkle triple this thing. And as you can see, I had to convert every spatial object that got plotted over here. And that again brings me to that initial point I was trying to make, is that you need to have all your data in one single projection before you plot it. If any of this was not transferred to this projection, and I'd plotted it in that same plot, it would have been like completely messed up, or maybe even not show up. So what projections do is they change the values of the XY coordinates. But if you look at the plot behind, if you remember that plot, the labels were still latitude, longitude. How was that possible? Because the data was now already converted to a different projection. And that was because I used specifically the projection for latitude, longitude when I specified my labels. So essentially what this is doing is it knows that the data is in a different projection, but it needs to represent it in the target projection, which is latitude, longitude. So that's what that code line does. And if it's too overwhelming, don't worry about this. I have all this in a R notebook that you can open from the GitHub repository. You can start changing stuff over there. You can like comment this out or try a different projection, see how that works out, right? It's all there for you to play with. But always remember, don't just go with the default projection of latitude, longitude, or God forbid, Mercator projection, right? Like that's probably the worst thing that you can use. You don't want to show Alaska as 1/3 the size of US. You don't want to show Greenland as the same size of Africa, which is what you get when you use Mercator or spherical web Mercator projections. Just research on what some good projections are and use them. What is extremely helpful is there's this website called projectionwizard.org. If you never looked at it, just go there. It has literally a selection box. You just select the area that you want to plot, and it will tell you what are the best options available for projecting this thing. As I said, there's not just one single projection. There are different projections. The choices depend on various other factors that I don't want to go to, but you'll still get these optimal projections for that particular area of the world. And you can go down deep into like a city level, or you can go as high as up to the world level. So I use this quite a bit when I need to figure out what projections I want to use. Just simple website, brilliant. So some other notes on creating plots. SP grid lines, as you already saw, for creating the latitude, longitude data. SP grid data when you want to show certain data in grid formats. That's another spatial container that I didn't go into detail much about, but just remember that it's a vector data format for storing grid level information. SP labels and SP text, fairly straightforward, self-explanatory. And then sometimes you really need to know what's the bounding box. What's the least area polygon that covers all your data. So that's like SPB box. And if you want to expand that a little bit, XPB box expand. So that's very useful that when you're plotting data. For raster data is pretty much plotted similar to how the vector data is plotted. You just like plot raster. I'll show you a sample call later on. But the thing is, when you want to transfer raster data, you are going to call raster project raster rather than SP transform. So, yeah. Yes. Yep. So if you take out a bounding box and then re-project your data, be sure to re-project your bounding box as well, or recalculate the bounding box as well. Good point. Thank you. There is a blog page by useR, the author of SF, who has another following this thing tutorial here later on about SF features. He has a web page called SP Gallery that has basically everything that you need to know about plotting SP. You just like you know how to plot SP using base, using ggplot2, some other specialized functions, right? It's one of the nice one-page reference. And SF plotting is discussed in detail by useR on that page, on the second page. And lastly, there's a guy called Robin Lovelace. How many of you know it? Yeah, he's one of the guys you should be following if you're interested in R spatial. He does a lot of like and geodata analysis for civic use cases, right? Like planning road maps, planning bike routes, those kind of things. And he has a really good repository where he introduces spatial visualizations. So every time I want to know something, it's one of these 3 pages that I end up going for base plotting. And again, Zevros, another key contributor to our JS ecosystem, has a very good blog post on just specifically raster data. If you want to know more about raster data, that's that one page that's going to tell you everything that you need to know about raster data. So we saw some plots with base plotting. Now let's move on to ggplot. So with ggplot, with base plotting, I can just take that SP object and just start plotting it, call the plot method. With ggplot, it's not that easy, especially for SP. You need to convert that data into what is known as the tidy format before you can plot it, right? So again, here the first part is pretty much the same thing. I took the European, the map of Europe. I excluded Russia from it, just the Western hemisphere of it. And then I had to add some unique IDs to each row in that. Each row represents a country in Europe, so I had to add a unique ID that is going to be used later on when I'm tidying up that data. So this is something that you need to do. Then I took a bounding box for Europe because like France has an island that is in the middle of Atlantic Ocean somewhere, and I think Norway or Sweden has an island which are almost like in the Arctic Ocean, which I didn't want to show. I just wanted to show you the hemispherical Europe part. So I wanted to exclude certain islands from the map of Europe. And the way I do that is I create a bounding box. I basically just went to that website that I showed you, a projection wizard. I just selected the area that I wanted to see. I saw what the bounding box was, and I created a spatial polygon from it. It's a really easy call, as you can see. Not really. I mean, like spatial polygons, list polygons, list polygons. Right? That's what you need to do to create a spatial polygon object. But and then once you see how easy it is to do this in SF, you'll start appreciating the beauty of SF even more. So this is basically a bounding box within Europe that I want my data to lie on. So I clipped the European region to that bounding box by using our GeoSG intersection. Essentially, it just gives me all the European polygons that lie in this thing, and it takes out anything that lies outside that bounding box. So even that is not enough because I'm still in SP land. The result of this is still an SP object. So now I need to tidy it up. So then I use broom tidy. There was a call called ggplot245. I don't know if some of you have seen that, but that seems to be like deprecated, and like Hadley also recommends that you use broom tidy. So you call broom tidy. But what happens when you call broom tidy is that you lose all the attribute data. You only get the spatial data in a tidy format. So you had a lot of attribute data, right? Like what's the population of that country, what's the GDP of that country, all that is lost. And now you need to recapture that by joining it back against the original data that was stored in your SP object. So already you can see the amount of steps that I need to take before I can plot SP object in ggplot2. I had to add like unique IDs to it, I had to tidy it up, and then I had to left join it with the original data so that I have all my attributes in line. If you miss any of these steps, or if this ID that you added was not unique, it completely blows up and your charts are like, you'll wonder what is happening. So yeah, I mean, these are important stuff that you need to do whenever you're working with SP objects that you want to plot with ggplot2. But the good news is the final code to actually plot is much more smaller. So if you remember some of that SP code that you saw behind, like it was like a bunch of things. With ggplot2, it's just simple and it's much more structured. All you need to know is which geomes you really need to plot. For plotting maps, there are two geomes, geome map and geome polygon. I suggest geome polygon. It's just much more easier to understand because you've already tidied up the data, you've already joined it to the attribute data. So geome polygon is just a little bit easier. Geome map is, I haven't shown a code map example with geome maps, but from what I remember, geome maps allows you to have your geometry data separate from your attribute data. That's the only advantage. I just use geome polygon, which, So I pass in the tidied data set. Now I need to tell which is the latitude, which is the longitude, what is the grouping for that so that all polygons are correct, what is, and how do you want, what sort of chart am I making? I'm making a choropleth map, so the color of the polygon will be derived from a value in the attributes. Here I'm just using the median estimated GDP for that country, and it's not per capita, it's the entire GDP, so just to be aware of that. Just pass in geome polygon, just set some alpha level, and then I'm using a different coordinate, using the coord map. So again, this AZ equal area coordinate system is suitable for European region, so that's why I'm choosing that. I'm using a slightly better theme from HRVR themes. If nobody has seen this, if you want to make print maps, if you want to make production ready maps, this is that one single theme that you want. Like it is specifically designed with typography in mind. You will get absolutely fabulous outputs from this one theme. Like there are a lot of other themes. I just love this one. And then basically Since I'm coloring the value, I need a color scheme. I'm using the Viridis color scheme, just giving it the name for the legend, and then basically other elements like chart header and a caption and stuff like that. So it's fairly straightforward. Once you get used to working with these kind of ggplot2 code, it just becomes second nature, right? It just really becomes that easy to start plotting with this. You don't really have to remember a whole lot. And the output looks like this. So I think here you can see the latitude, longitude values over here a little bit easier. And as you can see, obviously Germany has, for those of you who know your European countries without needing a label, Germany has the strongest GDP, obviously, and then followed by France and UK and maybe then, Italy and Spain, and then the other ones are now. So this is, open Financial Times or open Wall Street Journal and you'll see plots of this quality over there. So again, if you're doing data-driven journalism, look at ggplot2, look at HRBR themes. It just will give you amazing, amazing plots out of the gate. You don't even need to give this to like Photoshop for anything. Just take it, print it out. Sure. Yeah. So that was ggplot2 plotting with SF. Now we are going to, with SP. Now we are going to see how easy it is to do the same thing with SF. So I'm going to plot that same exact plot, but now with SF. And SF code, this is all there is to it. Like look at the data preparation code. It's much more smaller. This part is just basically getting the intersection, right? I mean, you had to do this part regardless of whether you are using SP or SF. This is just the common code to actually get to the data. But then I did not have to change that data in any way like I had to do in ggplot. I just plotted, gave that exact same SF object to ggplot. Everything else pretty much stays the same, except geom polygon now becomes geom SF, and the coord map becomes coord SF, because that's what you need to use when you're working with SF objects. And the coordinate now needs to be specified as a proch4j strings. There's a subtle difference between the way the coordinate system was specified in the coord map versus this thing. If you want my opinion, this is a little bit more verbose, but this is more accurate and this is more flexible, because proch4j is like the standard for specifying projections. So yeah, this is a little bit more accurate. Everything else remains pretty much the same scale, the same theme, just the same lab. So as you can see, it's much, much more condensed code, much, much more easier. Just take the SF object, plot it with ggplot2. And this is that same code. This projection is a little different than the one that was before. This is actually a little more accurate for representing European data. So it may look a little different than the other one, but otherwise it's the exact same plot that you got. So SF is, as I said, it's the future. If you guys are going to attend Edzer's tutorial after this tutorial, I highly recommend that you do. You'll learn so much about SF that you can literally take what you learn from that and what you learn from this and start making these kind of plots. Sorry, one more thing I needed to tell you about ggplot2 and SF is that the ggplot2 version that's right now on CRAN does not have SF support. You'll need to build ggplot2 from the repo in GitHub using DevTools. If all that made no sense to you, don't worry about it. Just look at building R packages from GitHub or something. Google for that and you'll find that out, how easy it is. But yes, you do need to build ggplot2 for now from the GitHub repository. So plotting raster data with ggplot2. Fairly straightforward, just a different call this time. I read the raster object and then I call geom tile on it. So you see those, because now it's plotted as a grid for each value that you have in the raster stored. Again, the same way of specifying the color and this thing. This time I wanted the coordinates to be exactly the same, like 1 unit north-south is the same as 1 unit east-west, and that's what coord equals does. No specific reason, I just wanted to show it as one more call. Sometimes coord equal helps when you're working with this kind of data, so that like north and south and east and west have the exact same thing. That's why you're seeing squares on the grid. Otherwise, everything still pretty much remains the same. And I could plot vector data on top of this just as though like geom polygon, geom point, whatever I want. Any questions about ggplot2 plotting? Most of you, since you have seen ggplot2, none of this should be really surprising except for the geomes. Sorry? Oh, yes. Good point. Thank you. Thank you for bringing that up. Yeah, I mean, the rasterwiz package, when you do that, it just does a bunch of things for you that you'll probably need to do manually by calling the ggplot2. Like, yeah, you're absolutely right. Here, I was earlier just calling ggplot2 over here. But here I am calling rasterwiz ggplot. This is just an easier way to modify that R data directly as ggplot2 needs it. So for me, whenever I'm working with raster data, which is not a whole lot, this is just easier for me. By the way, you can do a lot more base plotting also with rasterwiz. Gplot is just one of the functions that you have. So I have some notes for plotting with ggplot2. ggplot2 is used, since most of you know it, you're not really strange to any of these. But if you are new to ggplot2, there's a ton of stuff that you really need to know, like geomes, scales, legends, themes, facet. It just goes on. The good news is once you've internalized it, once you know that, then it's just second nature. Every time you see something, you know immediately what geom you're going to use, what legends you want, what themes you want. There are several ggplot2 extension packages. If you are not familiar with the ggplot2 extension ecosystem, check those out. Some of them can be used very effectively for plotting spatial data. I tend to prefer geom polygon over geom map, but that's just a personal preference. I should just say I prefer rather than you should prefer. As I said, if you are working with SP data, be sure to tidy it up and be sure to join it with the original SP data, otherwise it's not going to show up. And again, make sure that you're projecting all the data in one single projection. I've highlighted some of the good themes that tend to produce good maps by default. GG themes, theme map, HRBR theme, theme ipsum, ggplot2 theme, black and white. They typically tend to give you good map-related projections, themes. And then there is, instead of coord map, there's also something called ggalt coord proj, which you can use for like proj4 base. It's a little advanced topic. I've just put that as a note over here. When you really need to do that, just look that up and you'll get what I'm talking about. GeomSF, as I said, it's brand new. The support is still being worked on. It's not hit CRAN yet. So there are certain cases where you will hit bugs. In fact, I was getting some bugs when I was trying to put some other GeomSF-based maps. I mean, that's just the nature of the game, right? You're playing with cutting-edge technology, so you are going to get that. Okay. Yep. I can't quite hear you. Yeah, I haven't really created a whole lot with layout. I just need to see what layout does. But ggplot2 is extremely flexible. So it can allow, there is a package called grid extra, which allows you to lay out different plots on that same grid. It's called grid extra, and it just basically you say grid extra, some function I forgot, and just give it, like if you have 3 ggplots, you give them and then you tell it how to plot. So I think that's what layout does, right? It allows you to plot multiple plots on the same viewport. Yeah, exactly. So grid extra allows you to do that. Grid capital E extra. It is really flexible. Like if you really want to get into the deep dives of ggplot2, you'll need to learn how the grobs works, the graphical representation of an object or something. And once you know that, you can literally do anything with ggplot2. So there's another package called tmap, which is sort of parallel to ggplot2. It has similar APIs that you have like ggplot2, but it's not a ggplot2 extension, right? The output of tmap is not something that you can take and put into a ggplot2 map. The advantage of tmap though is that it is dedicated for thematic mapping of maps. So if you want to make maps really quick, tmap can give you really pretty graphs with a lot less or a lot concise syntax than ggplot2. Because ggplot2 is generic, tmap is specifically for map. There is a function called qtm, which just basically takes some data and you tell it, okay, do this for me, and it'll do it all for you. It'll figure out what it needs to do. If you want to be a little more verbose, then you have to use the combination of TM shape and TM feature. And that's where it differs a little bit from ggplot2. You can read about that. I don't want to go into the details of that, how it differs. But it does support many different map styles. It supports aesthetic elements like compass and legends and scales. So I highly recommend that you check out tmap if you haven't really checked out. And here's a little code for tmap. I'm just basically going to plot US population history. If you guys remember the animation that I had shown you before, where I had shown like the choropleth of US as various, at various years, this is an alternative representation of that. This is basically data preparation. This is the population history. These are the years for which I have the population history for. And then I'm just saying QTM, this is my data. Use the years column for filling the color value. Give the year value as the title for that. Just the title should be in red. This should be my title for the map. And then I use the color blind scheme for generating your colors, and use 2 rows for the faceting. So, and I'm using facets. So facet based on year, so that you have different maps for different year. And you'll see the output over here. So really nice, clean, concise output. Making this with ggplot2 would have been probably a little more harder than with tmap. But again, you get facets, you get choropleths, you get like symbols. You can even download base maps if you want to do that. So like you can have like base maps downloaded from Google Maps or OpenStreetData as the background layer for it. And again, once again, it's like fairly small amount of code to get really nice looking projection, like production quality maps. And it may be tempting to show like, date range values as animations. If it's like a small set of values, I would recommend you put it as facets rather than animation, because it's easier for you to compare every data point in that same chart. Whereas with animation, you kind of tend to lose the context, right? Here I can compare 2010 with 1990, whereas with animation, it's going to sequentially go from one to another. So there's no way to do that. So animation look nice and fancy. Facets allow you to much better explore the data. ggmap is an add-on for ggplot. It allows you to make maps with ggplot much more easily, because it's like geared for making ggplots. So if you are going to use ggplot, give ggmap a shot. It has some good inbuilt defaults. So this is the code for ggmap. Forget about this part. That's just code preparation, data preparation. I'm taking all the crime incidents reported in London from 2016-01 January to July. And now I'm going to make heat maps out of that crime data. And again, this is going to be a faceted heat map. So I have ggmap and I call qmplot instead of like that whole ggplot2 thing. And as you can see, it's not much. I just add some density for the heat map and the color scheme and this thing. The good advantage of ggmap, as I said, it's ggplot2 compatible. So once you have something coming out of a ggmap object, you can put in all your regular ggplot2 stuff in there and customize it even more. And this is a faceted heat map. Again, like with a very few lines of code, you see all the how the crime changed in London from January to July, or whatever is the intended. If you were to zoom into this, you will see the actual like the density bands. It's a little hard to see that when you're looking at this from a distance. But if you zoom in, you'll see all the density bands and how subtly that crime density changes. But look at the code. It's literally just like this much, 5 lines of code for getting that map. Any questions so far? Other options for plotting, cartography is another package which allows you to plot base maps much more easily. So you saw certain base map code before and it was quite verbose. If you want to work with base map, give cartography a shot. It was designed to aid in base map plotting of maps very simplistically. And essentially you just, like this is just data preparation. This is basically the internet usage of African countries in the year 2015 as a proportion to the population of that country. And essentially this part you've already seen, like plot Africa as this thing, plot its centroid. And then just make a circle for each country around the centroid, which is proportional to the internet usage of that country, right? So it's just one simple call. I haven't shown the output here, but I'll show you the output later on. It's there. I purposefully left it as an exercise to the reader to figure that out. So my advice as a GIS visualization enthusiast would be base graphics is powerful but unintuitive at times. Cartography package uses certain parts of it, so if you want to stay in that base graph ecosystem, look at cartography. TMap is extremely easy to get started. It's very flexible, but it's neither ggplot2 compatible nor base plot compatible. The output of TMap is you can't really augment it with base plotting or with ggplot2, at least not that I am aware of. And it has its own syntax that you need to know, right? Like ggplot2 syntax, you need to know TMap syntax. But TMap has another hidden feature, and it's not hidden really, it's wide open. It has a view mode which allows you to view that same map interactively. So if you want to do interactive plotting with TMap, it's also possible. ggplot2, you already know that, right? Structured API, very flexible, very powerful. ggmap and choroplethar, I haven't shown choroplethar code over here, but it's a package you can look into. And they serve as add-ons that make specialized plotting functionality. There are tons of extensions available for ggplot. And you can take a ggplot2 plot and make it interactive using the plotly package that I'm going to talk about when I reach the interactive. So that ends part one of plotting static data. We saw how to plot data using base mapping, how to plot data using ggplot with SP, SF object, raster objects. And then we saw certain helper functions like cartography and TMap for ease of map plotting. And that was all there is for static plotting. The last part of this is going to be interactive plotting. We are right on time. I have about 5 to 10 minutes if somebody wants a break before I start interactive, or if somebody has questions for static maps before I jump into interactive mapping. Sure. Not a whole lot. I mean, ggvis was started with a big bang and it sort of like died down. So I'm not even sure where it is right now in terms of like vitality. It saw a lot of promise and then sort of like, I think Hadley is kind of reviving it back up. So when that happens, definitely ggvis will have to be one of the things that goes over here. It's just I don't really know where ggvis right now is. Yeah, I mean, Lattice is another plotting ecosystem that is like you have base R plotting system, you have ggplot, and then there is something called Lattice. I didn't use Lattice because Lattice, I find it to be, well, it's a completely personal opinion and it's completely biased, so take it at its face value, don't read too much into it. I just don't see the value of Lattice. Like, I don't see what Lattice gives that I can't do with base R plot or with ggplot. I've already moved to ggplot for most of my plotting. It serves my need well. Why do I want to learn one more esoteric plotting system? Either I would do something in base or I would do it in ggplot2. But as I said, you know, this is a very biased opinion, nothing personally against the Lattice ecosystem. If you want, please, you know, like feel free to use it, read up about it. It's just, I find I have to remember a whole lot many syntaxes with Lattice, with base, with ggplot2. So it's just, that's the only reason why I don't use it. But I should probably add it to the slides, just as an option.
My question was more, obviously, ggplot seems to be the future.
Yeah, it is. I mean, ggplot2 is the future. Lattice was pretty big, I think 5-6 years ago, maybe 10 years ago. But so now ggplot2 is completely taken over. Okay, final 45 minutes, and everybody, thank you so much for staying with me so far. I know we've not done a whole lot of like interactive stuff, like coding and stuff. Just listening to me, blah, blah, blah. So thanks for that. Really appreciate it. Interactive plotting. Oh, great. See, I worked so much on it, I know the file names by heart, even if I don't even need to. Okay, that was the first glitch in the presentation so far. So far so good, right? If you want to quickly, if you already know ggplot2 and you want to quickly start making interactive plots, you have two options. The smaller option, well, I won't say smaller, but probably the easier option is something called ggiraf. How many of you know ggirafs? Just a little bit, yeah. ggiraf is really nice when you want to add a little bit of like that interactivity where you want to hover over points and see certain information, you want to highlight polygons, you want to see certain information, you want to click something. That kind of thing, ggiraf is really nice. It's just replacing the geom polygon with geom polygon interactive or what, something like that, right? Yeah, geom polygon interactive. That's about it. And then plotting it with the ggiraf code. That's about the only changes you end up making. And it works really nice in like shiny environments where you have that map that is essentially a static ggplot2 map, but you just want to have it a little bit more interactivity to it. So ggiraf is a package you should definitely look into. And the only thing that is different over here is that instead of geom polygon that you normally use, you use geom polygon interactive. Similarly, you have geom point interactive, geom line interactive, stuff like that. And the final plot is plotted using a ggiraf plot where ggiraf call where you say code equal to print g. That's all there is to it for ggiraf. And it's really, for a small set of APIs that you get, it's so powerful, the output that you do. So this is the output of ggiraf, and as you can clearly see, there is hover effect that whenever I hover, I'm seeing certain information that comes up for it. And if you want to look at the code again, it's just basically saying, where is it? Yeah. So I said tooltip equal to use the 3-digit country name and the internet population value for that. And that's it. ggiraf just does that all for you, right? Nice, clean, smooth. And everything else was the ggplot2 that you already know. I could have added hover effects, like whenever I'm moving through a polygon, it just kind of gets highlighted. Or I could have added some click effects where if I click on something, something else happens, like pop-up or a color change or something. Yep. It is, yes. Sorry, yeah, I should probably say that all the, I thought I already said that in one of the previous. All the interactive stuff that you see in this presentation or all the interactive stuff that you have for visualization is all HTML widgets based. So even if it works with ggplot2, it actually converts it into a HTML widget, which is basically our way of representing HTML code, JavaScript, CSS, images, what have you. So this is all HTML, yeah. It's not JPEG or SVG or anything like that. It's all HTML. It is actually SVG, yeah. But the moment I said that, I realized that was a mistake. I wanted to say it was not SVG, it is not BMP or JPEG or static images. It is all SVG actually. Thanks. So after ggiraf, the next thing that you can easily look into is Plotly. Plotly came from a JavaScript library called plotly.js or plot.ly. It is basically an HTML widgets wrapper for that JavaScript library. It is very easy but very powerful. The only limitation is that if you want to use it commercially, like if you have a newspaper, you want to put Plotly graphs on it, you need to pay for it. Like you need to have a paid version for it. But you can use it free for your development needs and stuff like that. Plotly plays really nicely with ggplot2. You can take a ggplot2 plot and plot. Like this is the code, right? This is your typical ggplot2 code. I have data, I call geom_sf on it. Now I'm just gonna do ggplotly on it, and I'm gonna add a highlighting effect to it so that whenever I'm moving on a polygon, it just gets highlighted. Now here's the thing, I would have loved to show you a demo of this. For some reason, this broke on my system, right? Like Plotly is not working on my system right now, and I couldn't get an interactive demo of you to play with. But I suggest that if you have, like Plotly installed, just try it out. Most of it you'll have success with that. The only reason I have a failure is because our ecosystem is kind of a mess all the time. So I develop a lot of packages, so sometimes I'm just pulling in something that I know is actually broken because I want to fix that. And I think something has been broken in that. That's why Plotly is not working. So all I can show you is code. I can't really show you output over here right now. But this code should work in a stable system. Sorry about that. And I actually wanted to show some more Plotly graphs, but since it was not working, I thought, what's the point, right? Next alternative to Plotly is Bokeh. Bokeh is a Python-based JavaScript library that came out of the Python ecosystem. Then they took out the JavaScript part of it, and then somebody built a R wrapper on top of it. It's not that well known, but it's really powerful as well. It has its own syntax though. So that's another thing is, one of the things that I want to highlight when I'm showing you all these choices is that these choices come at a price. The price is getting to know the syntax of these individual plotting packages and being familiar with that and realizing that you're not going to get that consistent set of syntax or APIs across these various plotting functionalities. So if you settle down on something, you just need to know what the syntax is like. So for n number of reasons, RBokeh uses this syntax, ly underscore, and then you have like ly underscore map, where I'm plotting a world map, and then I'm plotting points on that map. The rest of that other part was data preparation. So that's basically it. I mean, it's fairly straightforward API. And this is basically the world countries plotted, all the capitals of the world, right? That's what this is plotting, and it's showing you this. And this is again an interactive HTML, this thing. If I hover over a point, it shows me like the name, the country name, what the population of that country is. Wow, there is actually a population that has, like a capital of a country that has population 603. I'm from Bombay, so that amazes me. But and you have a lot of interactivity over here. You can use these panning tools. You can even save this. So Plotly is really, really powerful, right? It is. I would recommend that anybody who wants to get started with interactive visualization, start looking at Plotly. RBokeh is and Plotly both. So sorry, this is RBokeh. Plotly plot also has all these kind of options where you can save plots and stuff. Sure. I think so. I haven't looked into the details of it, but I think you'll probably be able to do that. Most of these interactive plot libraries do support projections, from what I last saw. I don't really know. I don't use RBokeh quite a lot. I'm a leaflet guy because I develop leaflet quite a bit. So my plotting is all leaflet based. But from what I know, a lot of these do support projections. Finally, before we move on to leaflet, one more plotting library, and again, choices. HighCharter, based on a JavaScript library called HighCharts. Again, it's a very popular library, but again, it's a commercial library. It's not free to put it in production use or commercial use. You need to pay for that. And again, has its own syntax, right? I mean, I really don't want you to read all this code as you sit over here, but once you go home, maybe you're looking at slides, then you can like look up at the code and try to figure out what is happening over here. And that's basically Australian population of some totally made up data, right? This was like, I had no data for Australia. The only data I could find for Australia was the kangaroo population, and that was only for 4 regions of Australia. So I thought, okay, that's not really good. So I just made up some data, like, I don't know. It seems like Northern Territory and Queensland are doing well, and New South Wales and Western Australia is kind of, that's about it. It's fun to play with made-up data, I'll say that. So finally, we come to the granddaddy of interactive plotting, leaflet, right? It's basic, mother granddaddy, whatever you want to call it. It is extremely powerful. It is extremely flexible. It can be a bit intimidating if you have never used it before. How many of you guys have used leaflet before? Quite a few. For those of you who have not, this is your introduction. It is based on an open source JavaScript library called Leaflet. Pretty much every web map that you see out there these days is running Leaflet most of the time, or Google Maps or Bing, but mostly Leaflet. The core package is developed by RStudio and actively maintained. I'm one of the contributors there. The 2 next packages, most of you might not have seen that. Some of you have seen that. Leaflet Extras and Leaflet E3, they were developed by me to add a lot more Leaflet functionality than the original package. They give you access to a lot of plugins. The Leaflet JavaScript library itself has a lot of plugins that you can use. And these 2 packages are used to integrate some of those plugins there. And lastly, there are 2 packages called MapView and MapEdit, which were developed by an organization called RSpatial. And they allow you to do interactive exploratory spatial analysis. So if you're doing like modeling stuff, like geospatial modeling or this thing, and you want to quickly explore your data, right? If you want to quickly explore the results of your model, if you want to quickly explore the data that you're going to put into model, try with MapView and MapEdit. They basically wrap Leaflet into easy APIs. You don't need to know all the Leaflet complex syntax, but it allows you to do interactive geospatial analysis on your data. So give MapView a try. MapEdit is fairly new. MapEdit is basically for editing geometries in the browser and then getting the results back into the R session and then again sending it back and forth. So that's what MapEdit does. There's another package called Leaflet capital R. In fact, if you were to read CRAN task view, you will see Leaflet R mentioned and none of these packages. I really don't know much about it. And I'm typically biased towards Leaflet because, yeah, I put some code over there. But the thing is, like, Leaflet is all about these plugins, these massive amount of plugins that you have access to for doing any kind of visualization that you can think of. And Leaflet Extras, Leaflet E3, those kind of packages will allow you to use those plugins. While as Leaflet R is just like that one single ecosystem. But it is still very powerful. So you definitely check it out and decide what works best for you. So if I have to give you one-page summary of what you can do with Leaflet, for those of you who have never worked with Leaflet, those are all the calls that you have. You pass your data to a Leaflet object. If you are working in Shiny where you want to update the same map again and again using newer data interactively, you pass the data to a Leaflet proxy object so that your map doesn't get destroyed again, but it just, you add or subtract to the same map instance that is present in the Shiny dashboard. And then you pipe various calls, just like you do in ggplot2. In ggplot2 you add, right? You use the plus operator. Here you use the pipe operator. Set view, fit bounds, set max bounds allows you to set the area that is going to be visualized, the latitude, longitude, the zoom level of the map. Add tiles, add provider tiles, add WMS tiles allows you to add the base map tiles that are going to be shown. Markers allow you to show various points. Polylines, circle, rectangles, polygons, very self-explanatory. That's what they show. Raster image allows you to display rasters. And then you have certain controls like you can add legends, you can add layer controls. I'll show you some examples of that. So essentially that's what it is. Like it's fairly straightforward, fairly easy, fairly intuitive. This is that one slide you'll need to know if you want to work with Leaflet. So let's see an example of base maps. I'm adding 4 different providers. The default provider is OpenStreetMaps, but then I have certain providers which are specifically like this is Car2DB, Dark Matter, Car2DB, Positron, different providers. Previous versions of Leaflet needed you to put that exact provider name in strings. Now there is a easier way to do that. There is a list called providers. And if you can like do providers $ and then hit tab, you're going to see that autocomplete list. There are about 200 different various providers. So it's easier for you to work with that. I add them to individual groups, and then I add a layer control, which is going to allow me to select which of those provider maps I want to show. So the output of that, if we have Wi-Fi strong enough, woohoo. Okay. So yeah, I mean, we are here, so why not Brussels, right? This is the OpenStreetMap. This is the Car2DB Dark Matter, and this is the Light Matter, or Car2DB Light. Easily changeable. You can have users given the choice what base maps they want to see. Markers, again, the various options that you need to pass to markers. Some of the interesting options are what is the label that you want to show when you hover over a marker, what is the pop-up that you want to show when you click on a marker. Do you want to cluster markers which are together so that it's visually more pleasing. And again, the groups for interactively seeing or unseeing the markers. And some other calls that have some flexibility. So let's see a quick example of how Leaflet markers work. All this part is data preparation, this thing, but what I'm essentially doing is I'm creating, there's a data set called earthquakes, which has earthquakes and they have certain, like the quake magnitude. So I'm splitting that into 3 groups of quake magnitudes less than 4.5, 5.5, and 6.5. I'm adding each of those individually to the Leaflet map over here, as you can see, and giving it a different group so that each of these 3 different sets is an individual instance added to the marker, and I'm adding a layer control which will allow me to select any of those groups. But now these are markers, so I don't want to select either one of them. I can select all three or just one, right? That's all there is to it. And this is the output over here. And this is a classic good use case for base map, selecting good base maps. These are earthquakes all around that Marinas Trench. If I had used the default OSM data map, the base map that you would have seen would have been a plain green image. Whereas by choosing a base map that is oceanic specific, you can clearly see that those earthquakes are happening around those fault lines, the trenches. So that adds a little bit of more context to your this thing. This is not maybe a point that you need to remember when you're just exploring data, but if you're putting that data out on a web page for people to consume, be careful about what base maps you choose. Just don't settle for the default one. That's the point. This is basically clustering that is happening. You click on a cluster, then it expands, and then you zoom out, it contracts. You hover over a marker, you see the value for the magnitude for that, and then you can easily select and deselect various groups of these, right? So as you select and deselect, the values will change. That's all really there is to it. And then you have a mini-map over here just to know where the context you are. So this is at a higher zoom level than, or rather a lower zoom level than the entire map. But it just shows you where that small area is in the global context. Sure. Split up the quakes database into 3 different data frames. Add the ocean base map as the provider tiles. For each of those 3 databases, this is just basically per way of doing walking lists. Add the database into the leaflet map and give its own group so that you can toggle individual groups. And then finally add the layer control for you to be actually toggle those groups. That's it. And add a mini map at the end, the small inset map that you saw. Leaflet shapes have some other options compared to markers. The biggest one that you might be interested in will be highlight option, so that when you are hovering over a shape, it changes its appearance so that you know that you are over that shape. You have options to add circles, add polygons, add rectangles, add like all these different methods. Basically all shape related options. So here's a quick shape example. What am I adding? What was that? Yeah, this is a choropleth map with population density of USA. Add polygon, give it a label that will be shown whenever I'm hovering over the polygon. Give it a highlight option so that it changes its background color a little bit so that you know where you are. And again, add a legend that shows you what that population density represents. And this is the output of it. Yeah, I haven't shown over here, but this SPDF was simplified using RMap Sheffer MS Simplifier so that the polygons are much faster plotted. One of the things that, as I think I mentioned it previously, again, RMap Shaper is really helpful when you have really complex polygons that don't need to be that complex when you're plotting, right? Just simplify them and do this. So this is it. You get the legend. It tells you what the population density looks like. Again, like India, China. And then see, this is the highlight effect that I was talking about. As you move over, the polygon sort of comes up and then you see a value for that. And you can obviously pan and zoom and everything. So fairly straightforward code. Yeah.
Does it work with the new SF classes also, or is it all spatial?
A leaflet now works with SF. I need to remember if the code was committed to. I think the CRAN version has SF support now. Yeah. And it's exactly the same. I think it's exactly the same call. You just say add polygons and you pass a SF object. The only limitation would be that if you have mixed geometry SF objects, it's not going to work because your calls are very specific to, like, either you say add polygon or add polylines. So if you do add polygons but add a SF object which contains markers, it's not going to work, right? It's going to blow up. So that's the only limitation. And obviously mixed geometries will not work. So there are a bunch of other miscellaneous stuff that you can do to your leaflet object. You can add plot raster, you can plot minimaps, you can add a measure so that you can interactively measure distances. So if you're doing like, I don't know, urban planning and you want to measure distances, you can just do add measure, and then you'll have a tool that will allow you to measure distances on your map. You can customize certain things by adding some controls and some actions that you can do with JavaScript. It's fairly well documented. All you really need to do is read up the documentation on this. Till about 4 or 5 months ago, Leaflet had only this way of plotting, right? Like this is called the spherical Mercator projection, where Greenland is the same size as Africa and Alaska is 1/3 the size of US, and it's completely wrong, but that just works good for, like navigation purposes and for basically web maps. So that's the one that was the only option. But now Leaflet has option to project the data in various alternative projections. I'm not going to take you into the details of that. This is mostly for you to read. The only thing you need to know is you need to create a coordinate reference system for your projection and pass it for your Leaflet call. So if you have used Leaflet but not really looked at projections, this is something that you can look into. So here is, I'm taking United, I think I'm taking World, and converting it into a Molvide projection, which is another projection that works for world data. Other than that, everything else looks same. I've added the graticules to show the latitude, longitude, but other than that, it's pretty much the same call, add polygons, everything else works the same. The only new thing over here is that this projection class, and I just wanted to show latitude, longitudes. So this is how it looks. Greenland is now cut down to its size, so apologies for anybody who's from Greenland, you're not as big as you think you are. And it's just a much better projection. So you have like various other projections. I just chose this one. I have another example with projections. This is for US, where I'm using a projection which is specific for US area, the Lambert equal area, something. Everything else is pretty much the same. In fact, this is an interesting plot because this is not using base maps at all. It's just using a SP object that has data that is moved out. And I'm just taking that SP object and plotting it, or I think right now I'm taking an SF object. 1 second. Maybe SP object over here. But everything else works. You have the highlight things working, you have the label effect, everything else works, but it's a much better projection of America than the one that you'll get normally. The only thing over here is I can't use a base map over here, because if I use a base map for this, Alaska is going to go all the way up there and Hawaii is going to go all the way up there, right? So, yeah. Yeah, that's a good question. The answer for that is one of those previous slides that I sort of went over very quickly. Since you asked, I'm going to tell you. SP uses, for output, it uses EPSG 3857, which is the web Mercator projection, the one that the default thing. But it expects all the data values to be specified in latitude, longitude, which is your 4326 projection, right? So it takes 4326 projection data and reprojects it into web Mercator. When you work with when you work with projections, what happens is it still expects the data in 4326. That doesn't change. But it will convert the data into your target projection. So a limitation over there is, let's say you already have data in that target projection, and you want to plot it with SP. You still need to convert it back to latitude, longitude, and then specify the target projection again, so that it works correctly. I've mentioned all that in detail. I didn't know whether I should have explained all that over here. But since you asked, yes, that's the thing that SP works with. There is a way to work around that, but for all practical purposes, that's how it works. So that was US. The third and final thing, because I wanted to introduce you to Tilegram's R package if you have not seen before. Again, I wrote it. It was inspired by the mess that was happening in the US election systems, where you had these US election maps where everything was red and just something was blue, and everybody was saying like Republicans are dominating everything. The politics aside, it's just a wrong way of representing data for n number of reasons. I don't want to go into the details for that, but the point is, with a lot of choropath maps, you end up plotting just the base area behind it and not really the actual value that you want to plot. So tilegrams are an alternative to that, and these were really popular when like they were, US polls and US election polls were coming up. So I sort of took some of that and made a package called tilegrams, which allows you to basically create these kind of values. If what you're seeing over here is each United States, where each hexagon represents electoral vote, right? Like the 538 electoral votes where each state gets that electoral votes. So as you can see, all these Midwestern states, which are huge in geometry, are like cut down to their size because they contribute so many small electoral votes. While as a small state like New Jersey becomes this big, and obviously, like these eastern states are that big. Texas is huge, again, California. So essentially the idea is to change the geometry such that it truly represents what the value that you're trying to plot. Here, it's being electoral votes, so that you get a proper interpretation of the data. If you have never really looked at tilegrams or before, go there. I have vignettes for that package. You can plot tilegrams for like US maps. You can plot tilegrams for French maps, for German maps. Any tilegram that I find, I take it and put that in that package. So yeah, it's if you want to do like election plotting, take a look at tilegrams. So two packages that I authored, Leaflet Extras and Leaflet E3, they add a lot of functionality to the base Leaflet package. Anybody works with ArcGIS or anything related to like ArcGIS, take a look at Leaflet E3 because it allows you to access the ArcGIS APIs within Leaflet. So you can just literally say, use this ArcGIS REST endpoint and plot the polygons that come up from that, and it's there for you, right? And now these packages are released on CRAN, so no more relying on GitHub. I actually published them just like 1 week ago or 2 weeks ago. But they are actively developed and maintained, and any contributions that somebody wants to make, like always welcome. And the idea now is to keep the Leaflet package very stable, not add a whole lot of functionality to it, and add any new functionality that is plugin based into Leaflet Extras. So what does Leaflet Extra give you? It allows you to interactively draw features and edit features on the fly, and work with that from Shiny perspective. It allows you to add GeoJSONs, TopoJSONs, KML, GPX, various different file formats directly as is, make pluralflets from it, make highlighting, everything. I'll show you an example. It allows you to create heat maps on your Leaflet maps. It allows you to search, a very powerful feature set where you have added a bunch of features, and now you want to know which feature is where. You can have a search box which searches the features. It allows you for tile caching. It allows for GPS, a lot more functionality. Like it's just a growing list of functionality that gets added to Leaflet Extras. So here's an example of adding TopoJSON data directly. I'm reading a TopoJSON, I'm adding it over here as is, and I'm saying that create a pop-up based on the properties that you find in that TopoJSON. I'm adding a label property and I'm adding highlighting to it. Doing this in directly Leaflet would have been extremely cumbersome. Doing it directly via TopoJSON, you get this. Okay, the base map is coming up. And I apologize for the misaligned these things. That is just something happening because of, yeah, there's something that is going wrong with Sharingan when it comes to that. But as I said, like with Choroplet's map where you're doing this, the limitation is you really don't know because you will always be biased towards this map where the polygon is large. Like larger polygons are going to bias your view on this data. And that was one of the reasons for that tilegrams package that I earlier showed you. But if you still want to use this kind of data for like, let's say a smaller data set like Philadelphia regions over here, one of the nice things that I have added over here is not only do you have this hover effect as you can see, but as you hover over a polygon, take a look at the legend. And it tells you where that value falls into, which is really nice because otherwise you don't have a clue based on just looking at the color where exactly. Because sometimes you can be confused, is that this color or that color from the legend? But now you can clearly see that wherever that legend falls into, that line is highlighted, that legend is highlighted. And alternatively, if another thing is, am I completely sure that this polygon and this polygon have the exact same color, or are my eyes deceiving me? Like what are all the polygons that have that same color? So if you come and hover over a legend, it's going to highlight all the polygons that have that value, which is, I find it really neat because it allows me to explore similar values much more easily, right? You just highlight, just keep on going into the polygons and it will show you which are all these polygons. Or alternatively, just go to a polygon, it shows you. So it's that bidirectional communication. And you literally didn't have to do anything over here except for, what was it? Nothing, you just had to add legend options. What was the title to that and what was this thing? And everything was done behind the scene for you by the package. You didn't have to do anything. So yeah, take a look at leaflet extras. There are tons of examples, but I just chose one. So crosstalk is a way of having widgets to communicate. So all the examples that you've seen so far were widgets, right? Like one instance of a HTML object, JavaScript, whatever you want to call it, doing something. But there is a way that you can make different HTML widgets talk to each other, and that is by using crosstalks. Now, crosstalks, the only thing that you need to know about is that you need to have a shared data that is going to be shared between the widgets that are going to talk with each other. The widget themselves has to support crosstalk. Crosstalk is not automatically enabled for all the widgets. The widget author has to change the code of that widget so that it supports crosstalk. So if you are playing with widgets, some of the widgets may not support crosstalk. So you create a shared data. Other than that, everything is same, but you select something called as BS call. That's just a call that you need to remember. And then I'm passing two widgets over here, a leaflet widget and a data table widget. And that allows you to access these things together. Unfortunately, I couldn't show the output of this in this slide, but if you go to the R Markdown, that thing is there, I think. Or if you go to the link that I've shown below, you can see this in action. But essentially what happens is you can select something on the leaflet map, it automatically updates the data table. You select something on the data table, it automatically updates the leaflet map. Bidirectional communication between widgets without need for Shiny. It's all JavaScript, all working in browser. Oh, okay, this is my first meme, Shiny. So I have a 7-year-old daughter and 5-year-old daughter, so. How many of you have seen Moana? Okay. It's a very, very annoying song. Like, I hate it and my daughters love it. So, this is my revenge. Shiny, how many people are familiar with Shiny? Okay, everybody is familiar with Shiny. That makes my job much more easier. I'm not going to demo Shiny over here. I'm just going to give you some sample code that you can look at. And you already know Shiny. So the only thing I have to you is some tips. Yeah, as I said, everything interactive visualizations. One of the key things that you know about Shiny is that if you are building maps, ggplot2 maps, like static maps, or interactive visualizations like leaflet high charters, when you make that call as part of a trigger, like something data selected, button click, the original plot is destroyed and a new plot is built, which can be time consuming, which can be slow. So at least for leaflet, and I think also for plotly, the option is to retain the plot that was already generated and just plot over that, right? Maybe destroy the data that was used to plot in the original plot, but plot it with a new data, but not completely build the plot from scratch. And that is something that you need to, if you use Shiny a lot, you'll do that a lot, especially with leaflet and with plotly. Don't destroy the plot, just use the existing plot and plot over it. So plotly and leaflet do support that. Some other widgets also do support that. Another option to very quickly get started with Shiny, if you don't want to do that whole thing, server, GUI, server.r, GUI.r. There's a package recently that came out called, it's not recent, it's been there for a while, manipulate widget. It allows you to do that exact same thing that you can do with Shiny, but it's just much more easier. So you just say manipulate my leaflet widget. I want controls to be built for this parameter, and it figures out and it makes you like it either gives you like that select boxes or input boxes and everything. It does all that for you, and then you just interact with it like a normal Shiny application. So I find manipulate widget more than adequate whenever I really want to use Shiny. I'm not a big Shiny user, but that's manipulate widgets is something you can easily look into. Specific tips for leaflets and Shiny, as I said, don't call the leaflet object again after you've already made it. Use the leaflet proxy object within your responsive calls, like within your, what's that term, reactive code, right? So that your leaflet object is not destroyed. There is a method called clear, just like you saw those methods add polygon and stuff. There are methods like clear polygon to destroy already data on the map. And then leaflet package traps many leaflet JavaScript events and makes them available as Shiny events that you can listen on to. So essentially what you can do is, if you have something that you want to do something, like if you have points, so you want to click something on the point and you want to execute corresponding Shiny codes, the leaflet package is going to emit an event and you're going to have to trap that event calling observe event, giving the map ID and the event name, and then you can work on that event. So it's a bidirectional communication of interactivity and Shiny. And it's very fairly easy to work with. You just need to know what event you need to trap and then do whatever you need to do on that event. So this is the Shiny code that I literally took from the RStudio website. I didn't want to spend a whole lot on time on Shiny. Essentially, this is your UI, this is your server. You say output.map, and you say render leaflet. That's the call to render a leaflet map, and I'm generating a map over here. That's really there to it. If I wanted to add some interactivity to it, as part of like that reactive in output stuff, instead of leaflet over here, in that call, I would have called leaflet proxy so that I'm working on that same map again. That's pretty much basically it for as far as Shiny goes. So yeah, that marks the end of geospatial visualization tutorial by me, the first of his name. How many of you get that? Any fans of first of his name? But there is something more. So these are the people I would like to thank. Bob Rodis, obviously my mentor and teacher, amazing guy. I think I have linked all of their Twitter accounts. They are really active and they tweet out really interesting geospatial visualization related stuff. From time to time, you can follow them. I've pretty much listed out everybody that I know of and I regularly follow. So yeah, that's it. That is on time and so before I take questions, first of all, thanks so much for being so patient with me. I know that there was a lot to take in, right? Like it was literally jam-packed with so many options. But I wanted to purposefully overwhelm you with options, if I can say that. And the reason I wanted to do that is just to make you aware how vast and rich that our ecosystem is and how much you can do in terms of geospatial analysis and geospatial visualization just by staying within R. And if you have not done it before, now is your time to start exploring that. You don't really need to know all of these packages and all of these things in detail for these things. Just pick and choose, right? Like just what works for you. You want to make ggplot2 maps, just go with that ggplot2 stuff that is there. You want to make interactive maps, you want to keep it simple, just use Plotly or HighCharter. You want to get that more power, just go with Leaflet. Just be aware of that whole ecosystem and then pick and choose wisely. That would be my advice. So with that, any questions? We still have about 5 to 7 minutes. For some of the stuff that I did for the plugins, the plugins themselves are JavaScript as well. Some of them had kind of bugs or not were really working properly. So when I brought them into the JavaScript in the art world, I fixed those plugin codes and contributed it back to the original JavaScript authors as well. So yeah, I mean that has happened a lot with Leaflet extras. A lot of the time, some author will write a plugin that works. He's fine with it, but then doesn't really develop. And then if you want to use that, yeah, there are deprecations and you need to fix that. So yeah, I mean, I have done that. I've fixed some Leaflet plugins in JavaScript as well. Thank you. Yeah.
What is the reason for the manipulate widget function when you already have the leaflet proxy function? Or is manipulate widget?
Well, even with Leaflet proxy, you still have to manually add your UI controls and everything, right? Like you need to, if you want to say, certain drop-down list. You need to create the UI elements for that and then hook up the functionality, right? Manipulate widget does that for you automatically. You just tell it what UI widget it wants, and it will generate all the code for it. Like it's a one-shot call that generates a whole lot of code for you that you don't need to do that. So that's the reason for manipulate widget. There was one more, yeah?
Is there a way to use the leaflet interactivity when being offline?
Yes, there is a way. If you are offline in a Shiny environment, no, right? Because if you need a Shiny server at the backend to talk to, I don't think there is anything like Shiny offline, unless there is, maybe I'm missing that. But if you are just working with a leaflet, straight up HTML widget coming from a website, then for at least the things like base maps and stuff, I think, yeah, there is something called tile caching. So you can pre-populate your leaflet map and cache those tiles in your local session and work offline on that. So, yeah. Yeah.
Also about the offline issue. So if you can you do all this also if you have a local Shiny server in a completely enclosed environment and has no internet connection, that you download the
So
yeah.
for example, this plot, right? To make the choropleth and the legend and everything, all you really need is that local environment. You don't need to go anywhere outside. The base maps are coming from the internet. So if you don't have internet access, you should either have a local map server that is running and serving out base maps, which is, believe it or not, it's fairly easy to do. Like there are Docker images, once again, Docker to the rescue. There is a Docker image that you can do that will pull all the OSM base map data and give you base maps from OSMs within your local environment that you don't need to do to go to this thing. And all you really now need to do is add tiles and the URL for where that local image is running. So either you like download it offline, cache it, or I think it also works with file-based URLs. So if you have there is a scheme as to how these tiles are stored. And if you just download that into a local directory and specify add tiles, and the URL is a file URL, it will still work. But you have to have it available offline. If you don't have it available offline, you're not going to get the base map. But it's only the base map part. Anything else? That's it? I think we are on time. Okay, thank you everybody.